Hello Longhorns, this is the test 2.2 review, and I'm going to start with question number 2 on the review. And first thing we need to do is we need to isolate y so that we can graph this absolute value function. And the first thing I'm going to do is I'm going to multiply both sides of this inequality by a -2. And what that will do is that will allow me to get that y isolated. So let's go ahead and take care of this. Okay, so notice how when I multiplied both sides by the -2, this fraction goes away, and okay, this fraction goes away, and this part of the function right here on the other side of the inequality, we're going to only multiply this negative sign, which is really a -1. We're going to multiply that by -2. That's what gives us this +2 right here. We don't do anything to this absolute value because this absolute value, we can't multiply anything in between these bars. So this expression right here, this absolute value expression, needs to be left alone. You cannot multiply through it. You can't touch it. Just leave it the way it is. And then the last thing we're going to do is multiply this -1 by -2, and we get +2. So we end up with the inequality y is less than 2 times the absolute value of x plus 3 plus 2. And I'm going to start by graphing my vertex, which is going to be -3. That comes from here. So remember, we got to change the sign to negative, and then +2. Okay, so as you can see here, I've written the vertex -3, 2. And then I'm going to graph that point. That point's right here. The next thing I'm going to do is determine what my a value is. My a value for this function, this inequality, is 2, or 2/1. So what I'm going to do is I'm going to go up from the vertex 2 points and over 1. And that's going to give me my next point for my absolute value. So I'm going to go up 2 over 1. And up 2 over 1 on the other side. And then since this is an absolute value, I can keep doing that. I can do that again. It's like a linear equation, but both sides. So this is what we get. Now, the one thing that you need to remember here is that these lines right here should not be solid. So I'm going to take my little eraser here, and I'm going to just make that a dashed line because this is a less than, it's not a less than or equal to. So since it's not equal to the line, I can't make that a solid line. And then I'm going to shade the rest of the graph. Now this says y is less than, so I'm going to go under my vertex. So anything under my vertex is what is going to be shaded on this graph. And I can just shade the whole graph. And you probably shade prettier than I do, but I don't color very well, so I'm going to do the best I can. But all of this part here is the shaded part. The part inside the absolute value is not shaded. And that's all you have to do with that. Okay, the next graph we're going to do is graph number 4. This is also an inequality, but this one is not an absolute value. This is a quadratic function. So I'm going to go ahead and graph this function for you, and then I'm going to talk about some of the attributes. Alright, so I began with our vertex, which is 3, 2, and that's this point right here, 3, 2. And then I went ahead and I graphed a couple other points. Now I know that my value for a is 2, so if I go over 1 and up 2, that'll get me to my next point. Now that works fine for absolute value functions. We could keep going like that, but with quadratics you can't. With quadratics, if I go over 2, remember I have to go up 4, but since I'm multiplying 4 times 2, I have to go up 8. So if I go over 2, I've got to go up 8. So that puts me at this point right here. Now, if you're not sure where to graph those points, you can also use a table. A table works just fine as well. So just remember, if you're using a table, you're just plugging those values in your table in for x and solving for y, and that'll give you your points for your parabola. Okay, so what I want to talk about are where the solutions lie. Anything inside this parabola, because this says y is greater than or equal to the parabola, so that's going to be all of these points inside here, and any of these points would satisfy this inequality. Also, this parabola is solid because of the equal to. So all of the points on the parabola itself are also solutions to this inequality. However, if this was not an equal to, if this parabola was a dotted line, then those points on the parabola would not be a part of the solution. So be very careful with that on the test, because on the test you might get a parabola that has a dotted line, and those points on the dotted line are not, or on the dotted curve, are not part of the inequality solution. If you're not sure, you can always plug the points in to your inequality and then just check to see if the statement is true. That's always another way you can check to make sure that you have the right point. The other thing I want to note about this particular parabola, if you notice that it's kind of floating up here in quadrant 1, and it doesn't cross the x-axis. So since this parabola does not cross the x-axis, this is the x-axis, there are no x-intercepts. So be looking for that on the test as well. You may get a parabola that's floating up here, or maybe it's floating down here, and if that's the case and it doesn't cross the x-axis, then it doesn't have any x-intercepts. In that case, you would just say none. There's no x-intercepts. Okay, for a problem like number 6, we are to graph the quadratic equation, determine the vertex, its axis of symmetry, x-intercepts, and the range. So I'm going to start with the axis of symmetry. Alright, so our formula for axis of symmetry is x is equal to negative b over 2a. This is a formula you need to memorize. If you haven't already memorized it, it's part of the quadratic formula, so it's easy to remember that way. X is equal to negative b over 2a. This is going to give us the equation of the line for the axis of symmetry for our parabola. Alright, so as you can see, I have substituted in a negative 2 in for b. So where did I get that negative 2? That comes from this number right here. So this number right here is my a value. In this case, it's negative 1. This number right here is my b value. That's negative 2. And this number right here is my c. So a squared plus b plus c, or plus bx plus c. This is going to be my quadratic equation in standard form. Okay, so what I've done is I've taken these values for these coefficients and I've plugged it into my formula. So I have a negative b, so negative negative 2. So because it's a negative negative, it makes this 2 a positive. And then I have 2 times a negative 1, which gives me a negative 2. So all in all, when I'm done, I have x equals negative 1 is my axis of symmetry. And I can go ahead and draw that axis of symmetry in to my graph. So it's just a vertical line going straight up and down. And it's really kind of invisible, so I'm just going to go ahead and make that a dashed line, just so that you know it's not really a physical line on the graph. It's just an axis that we're splitting our parabola in half with. Okay, so I'm going to go ahead and start with the vertex, and I'm going to graph some points, and then I'm going to show you some other attributes about the parabola. Okay, so how do I get my vertex? Well, I know that x equals negative 1 is my axis of symmetry, and I know that my axis of symmetry goes straight through my vertex. So I know that the x value for my vertex is also -1. So I can take that -1 and I can plug it back in to my equation and I can find y. And that will give me the y value for my vertex. So that's what I've done here. I get 4 for my y value. I've plugged it in, -1, 4, and this is the vertex of my parabola. Now I also know that my parabola opens downward because of this negative sign right here in front of my x squared. So I know my parabola is going to open down, and I also know that this is a regular parabola, it's not stretched. So I'm going to go ahead and just graph a regular parabola. Okay, so there's a couple different ways you can get your points for your parabola. So what I'm going to do is I'm going to find my next point by counting over from my vertex. I'm going to count over 1 and down 1. So, or down 1 over 1, whichever way you want to look at it. So if I go down 1 and I square 1, I get 1. So 1 over 1 is going to be my next point from my vertex. And then I'm going to do the same thing in the other direction, because whatever I do on this right side of my axis of symmetry, I also do to the left side of my axis of symmetry. Okay, so the next point I'm going to go over 2 and down 4, because 2 squared is 4. So I go over 2 and down 4. 1, 2, 3, 4. This gets me to the next point on my parabola. Now you can do it that way, or you can just make a table and find your points. Either way is fine, it doesn't matter. This is a quicker way to do it. If you don't feel comfortable doing it that way, just go ahead and make a table and find your points that way. Now I found that I have 2 x-intercepts, so those are a couple of the things that we have to identify on our graph if we have any x-intercepts. So far we have our axis of symmetry is x equals -1. We have a vertex of -1, 4, and then we have our x-intercepts. And our x-intercepts for this graph are 1, 0 and -3, 0. And if you're not sure if those points are correct, you can always plug the 1 back into your equation and check it, or plug the -3 in to your equation and check it, and make sure that y is 0 when you do that. The last thing we need is the range, and our range for this parabola, since it opens downward, is going to start at -infinity. So our range starts at -infinity and it goes all the way up to 4, and including 4, so I'm going to put a box around it. Another way we can write range is y is less than or equal to 4. You could write it like that as well. So a couple different ways we can write range. Alright, so this test has a lot of word problems on it where you've got to set up systems and then solve for the system. So just make sure that at the end that you're answering the question that it's asking. Because if you don't answer the question it's asking, then you're going to get the problem wrong. One of the things that you have to do is you have to set up the system. Now once you set up the system, there are several options for you to solve the system. You can solve by substitution, elimination, and also graphing, and we know how to use the TI Inspire to enter the system of equations into the algebra function. So if whichever way you decide to do it is fine. If it asks you to solve it in a specific way, then that's the way you have to do it. For example, if it says solve by hand, or solve by elimination, or solve by substitution, then you have to solve using that specific method. If it doesn't say a method, then you can use your calculator to solve it. Alright, so the first word problem we're going to look at is number 8. This is similar to one of the problems on your test, so I wanted to work this one. I'm going to go ahead and set up the system, and then I want to talk about how I set it up. And then this one, you can solve any method, so we're just going to use the calculator. Alright, so this problem says, at the Apple Pan, 2 burgers and 3 orders of fries cost $19.75. So here you can see where I've set up this equation. 2x, where burgers are x and fries are y. I have 2x plus 3y equals 19.75. 5 burgers and 2 orders of fries cost $37. So 5 burgers plus 2 fries equals $37. Now, since I have this already set up, I can put this in my calculator and solve for X and Y, and that's what I did. So if Coach Reeves bought lunch for Miss Vaca because she is so nice, and they each had a burger and an order of fries, how much would the cost be before tax? Well, we found that when we put this in the calculator, we got that X was $6.50. So each burger cost $6.50 and each fries cost $2. So I just put those together. So 2 times $6.50 plus 2 times 2 gave me $17. So the total bill came to $17 before taxes. All right, for the next problem, we have at Vaca's Printing Company, LLC, there are 2 kinds of printing presses. Model A, which can print 70 books per day, and Model B, which can print 55 books per day. Vaca Printing owns 14 total printing presses, and this allows them to print 905 books per day. How many of each model of presses do they have? So what I've done is I've set up the 70 books per day, so 70 times X with Model A and 55 times Y for Model B, which equals a total of 905 books. And then I did X plus Y, the total number of machines. So machine A plus machine B equals 14 total machines. So now what I'm going to do is determine how many of each kind of machine we had. So we pop this in the calculator and we get that X equals 9 and Y equals 5. So there are 9 Model A machines and 5 Model B machines. Okay, in problem number 10, the school that James goes to is selling tickets to a fall musical. On the first day of ticket sales, the school sold 7 senior citizen tickets and 4 student tickets for a total of $144. The school took in $192 on the second day by selling 1 senior ticket and 12 student tickets. What is the price of a senior citizen's ticket and a student ticket? Okay, so we just set it up. 7x plus 4y represents this first purchase for the first day, and x plus 12y, so only 1 senior ticket, so x plus 12y equals 192. Put that in the calculator, we get x equals 12 and y equals 15. So there were 12 senior, or the cost for senior tickets is $12, and the cost for a student ticket is $15. Okay, in the next problem we have Mrs. Stiles, that's my mom, restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. How many of each type of flower was ordered? Okay, so, and we also have a hint here that this is 3 variables. So we're going to identify our variables and set up our system and then solve using the calculator. Okay, so after setting up the systems, we have $1.50 times X, which represents this $1.50 for the carnations, $5.75 times Y, which is the roses, and then $2.60 times Z for the daisies, and that equals $589.50. Let me get that in there. $589.50. Okay, then our second equation is X plus Y plus Z, all of the flowers together, equals 200 flowers total. So we have to have an X plus Y plus Z equation in there for the total number of flowers. That would be this equation. And then the last hint we had here was that they had ordered mostly carnations and 20 fewer roses than daisies. So 20 fewer roses than daisies would mean that our roses were daisies minus 20. So 20 fewer roses. So then we went ahead and put this in the calculator, and we got that we have 80 carnations, 50 roses, and 70 daisies. Okay, for problem 12, we have last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. Proceeds totaled $64,600. Tickets can be bought in one of three ways. A matinee admission costs $5, student admission is $6 all day, and regular admissions are $8.50. How many of each type of ticket was sold if twice as many student tickets than matinee tickets were sold? Okay, well, we identify our variables. X is matinee, Y is student, and Z is regular. And you'll notice that all through this review, I have identified my variables as X, Y, Z. And there's a reason for that, because when we put this in the calculator reads X, Y, Z. It does not read any other variable unless we change it in the calculator, and we're not going to do that. So it's easier for us to just stick to X, Y, Z so that we can put these in our calculator. All right, so the first equation I have is that all of the tickets added up to 8,500 tickets sold. So X plus Y plus Z equals 8,500. That's this part right here. The next part is assigning a value to each one of the variables for the price of each kind of ticket. So 5 times X for the matinee, 6 times Y for the student ticket, and $8.50 times Z for the regular. And the total proceeds were $64,600. So all of these amounts are dollars. Then the last hint they gave us was that what was the last hint they gave us here? How many of each type of tickets? If twice as many student tickets than matinee tickets were sold. Okay, so that would be twice as many student tickets. So this is Y represents student tickets. So we take the matinee tickets times 2. That's going to give us how many student tickets we have. Okay, so we put this system in the calculator, and what we get is that the X value is going to be 900. So there was 900 matinee tickets sold. There was 1,800 student tickets sold, and 5,800 regular tickets sold. For the next problem, we have write the quadratic equation using y equals ax squared plus bx plus c. And all they've given us is 3 points on our parabola. So I'm going to show you how to find the equation using a systems of equations, and then we can find the values for a, b, and c. All right, so the first thing we're going to do is use each one of the points that we've been given to set up a separate equation for our system of equations. And this is going to be a system of 3 equations and 3 variables. So the first one we're going to do is we're going to take this -4, -10, and we're going to set this up into our quadratic equation. So y is -10, so this is y. Y is -10, so I put -10 here, equals a times, and then everywhere there's an x, I'm going to put -4. -4 squared plus b times a -4 plus c. And then I simplify this. And I get -10 equals 16a. Now remember, this is always going to be positive because we're squaring this negative number, so this is going to be a positive 16. Minus 4b, that's going to be a negative sign, plus c. This is going to be my first equation that I'm going to put in my calculator for my system. The next equation, I'm going to do this again, except I'm going to use the second point. So -10 equals, and then I plug in the other -10, which is the x, into each one of the x's, and I simplify, and I get 100a minus 10b plus c. That is my second equation for my system. The third equation is going to come from this third point, and that's going to be 6 equals a times a -6 squared plus b times a -6 plus c, which gives me 6 equals 36a minus 6b plus c. That's my third equation of my system. Now I'm going to put these 3 equations in my calculator, and I'm going to solve the system, and what the calculator gives me is that x is -2, y is negative 28, and z is negative 90. All right, so remember that when you're putting these values into your calculator for A, B, and C, you're using X, Y, and Z, not A, B, and C. If you put A, B, and C in the calculator, it's going to give you an error message. So make sure that you're converting these A, B, C when you put it in your calculator, that you convert this to X, Y, Z. Otherwise, you're not going to get the right answer. Okay, so we've got this value for A, this value for B, and this value for C, and we just plug it in to our equation. So y equals, we fix that, it should be an equals, y equals 2x squared, and that should be a negative 2x. Forgot my equal sign. Y equals a negative 2x squared minus 28x minus 90, and that's going to be the equation for this these set of points. Now, if you wanted to check this to make sure that you got it right, you could actually graph this in your calculator and go to the table and check your table to see if these points are in your table. You could do that if you had time to check your work and you wanted to check it, you could do that. Graph this, go to the table, see if these points are in your table. If these points are in your table, then you did it right. Okay, for problem 15, this is going to be a system of inequalities. And we start with Claire babysits for $4 per hour. She also works as a tutor for $7 per hour. She is only allowed to work 13 hours per week. So when we add up her two jobs, X is sitter and Y is tutor, when we add up her two jobs, those hours need to be less than or equal to 13. She can't work more than 13. Okay, so each job pays $4 per hour for the babysitting, and then $7 per hour for the tutoring. And so that total can be greater than or equal to 65. So when we solve this system, we get that y is greater than or equal to 4.3, and that x is less than or equal to 8.7. Well, we need to look back at our equation and say, well, what x value and what y value can we have? Well, we can have an x value of an x value of 9, so we can actually round this up to 9, and we can have a y value of 4, and that will give us 9 plus 4, which gives us 13. Or we could do x is 8 and y is 5. We could do that. And so if we plug that in, if we did y is 5, which is probably what we need to do since y is greater than or equal to 4.3, we're probably going to have to go up to 5 for y. Then we would put 5 in for y, and x would be 8. So that's probably the numbers we're going to need to use here. So x needs to be less than or equal to 8.7. So we're gonna say that the sitter hours for sitter is going to be 8, and for tutoring is going to be 5 is going to be 5 for tutoring, and that's it. Okay, I recommend that you work all of the word problems on this review sheet. I didn't work them all on this video, but I recommend that you work them all to get ready for this test. And if you have any questions, please bring them to class, because once we start the test, I'm not going to be answering any questions for you. I'm not going to answer how to put something in the calculator. I'm not going to answer how to set up a system. So if you're not sure how to do that, or if you're struggling with this material, you need to come to tutorials to get some help, and I will be very happy to help you out.